In this video, we're going from a blank folder to a working little web app, using Codex as a coding teammate. And I want to be clear up front, this is not AI magic. It's a workflow. Codex can be fast, but only if we keep the scope small, test as we go, and actually review the code it produces. First, let me show you the result we're aiming for. This is a focus timer web app. It has start, pause, and reset. I can adjust the focus minutes and break minutes. It remembers my settings after refresh. And by the end, we'll add a small polish feature, a progress ring plus a session counter, so it feels like a real product instead of a throwaway demo. So what is Codex in plain English? Think of it as an AI coding agent. You tell it what you want. It proposes code changes. And you iterate, like you would with a teammate. The difference is, it's extremely fast at generating boilerplate and first drafts. But that speed can be dangerous if you treat it like an autopilot. So for this demo, we're following 3 rules. Rule 1, small steps. 1 change at a time. Rule 2, run and test early. If you don't run the code, you don't know anything. Rule 3, review diffs. We're not accepting mystery changes. Alright, let's build it. I'm starting in an empty folder. I'm going to create a folder called Focus Timer. Inside it, we want 3 files, index.html, style.css, and app.js. Now, prompt number 1 is the scaffold prompt. And I'm going to keep it specific. Create a small single-page focus timer web app with index.html, style.css, and app.js. It should have start, pause, and reset. It should have adjustable focus minutes and break minutes. It should look clean and modern. It should store settings in local storage. And keep it simple, no frameworks. When Codex responds, I'm looking for a few things before I even run it. Do we actually have the 3 files? Is the code organized, or is everything jammed into one giant function? And are there obvious red flags, like global variables everywhere, or weird duplicated logic? Okay, we have the files. Great. Now I open index.html first. I'm checking for basic structure, a clear container, a display for the timer, controls for the buttons, and inputs for the settings. If I see semantic issues, like missing labels or inaccessible controls, I make a note, we'll fix those later. Next, style.css. I'm looking for a simple layout, centered timer, readable font sizes, good contrast, and buttons that look clickable. Because remember, this is a YouTube video. Visual clarity matters. If the UI is tiny or low contrast, the demo will feel worse. Now app.js. This is where most AI-generated bugs show up, because timers are stateful. So I'm scanning for how it stores remaining seconds, how it updates the display, and how it starts and stops the interval. Now we run it immediately. I open index.html in the browser. I click Start. The timer should count down. I click Pause. It should stop. I click Start again. It should continue from where it left off. I click Reset. It should go back to the starting focus minutes. So far so good. Now I try to break it on purpose, because if you don't do this, the bug will show up later when you're editing. First, I refresh the page. Do my settings persist? If not, local storage isn't wired correctly. Second, I try to change the focus minutes while the timer is running. This is a classic edge case. If the app lets me change the minutes mid-run, what should happen? There are 2 reasonable choices, either you disable editing while running, or you apply changes only after reset. But the worst outcome is when the UI half updates and the timer logic disagrees with the display. If everything still looks correct, great. But if we see a glitch, like the display jumping, or the remaining time resetting unexpectedly, that's our first debugging moment. And here's prompt number 2, the debug prompt. Notice how I'm telling Codex exactly what the symptom is, and what kind of fix I want. The timer UI gets out of sync when I change settings while running. Please fix this by separating setting state from runtime remaining seconds. And either prevent settings edits while running, or apply changes only after reset. Show me exactly what you changed and why. Now, when Codex proposes a fix, I don't just click apply. I scan the diff first. Did it touch only the relevant files? Did it introduce a new state variable that makes sense? And does it reduce confusion, or add more? One common AI failure mode is, it adds more and more state flags. Like, is running, is paused, has started, should reset, and so on. That's a smell. We want a minimal state model. Okay, apply the fix. Now we rerun and retest the exact same steps. Start. Pause. Reset. Change settings while running. Refresh. If the bug is gone and nothing else broke, we move on. Now for prompt number 3, polish. This is where the video becomes satisfying, because the app goes from functional to nice. Add a polished progress ring around the timer, and a simple session counter. The progress ring should animate as time passes. Increment focus sessions completed when a focus timer finishes. Keep it accessible and lightweight, no canvas libraries. And update the CSS to look modern, with good contrast. When this change comes in, I'm watching two things. First, performance. We don't want to re-render the entire page 60 times a second. A timer ticking once per second is fine. Second, accessibility and clarity. Does the progress ring reduce readability? Are buttons still obvious? Is the text still high contrast on a dark background? If you're building for YouTube, also remember, your viewers may be watching on a phone. Alright, we apply the change, and we test. Start the timer. Watch the progress ring move. Let a session complete, or fast forward for the video, and confirm the session counter increments. Refresh the page and confirm settings persist. And at this point, we have the core promise of Codex demonstrated. We use 3 prompts to scaffold, debug, and polish. Now the most important part, what actually made this fast? Because the tool is not the main story, the workflow is. Here are the 3 principles. Specify the outcome. Tell it exactly what files you want, what features you need, and what done looks like. Constrain the solution. Keep the scope small. Say no frameworks. Say lightweight. Give rules. And verify early. Run it immediately. Try to break it. Review changes. Don't accept mystery edits. And here's my quick review checklist. Does this change match the request? Is state handled cleanly? Are errors handled? And did we accidentally add complexity we don't need? If you want, I'll turn this into a series, one small build per video, with real debugging and real code reviews. Comment what you want me to build next, a personal budget tracker, a mini flashcard app, or a browser-based notes tool. And if this helped, subscribe, because the next videos get even more practical.